7.4, applying circular functions. Basically what we're saying here is that the family of sine functions and the family of cosine functions can be used to model real-life situation problems. And these problems will occur wherever there's regular patterns, cyclic kind of patterns. Whenever we're modelling, it's really important that we thoroughly read the question and completely understand exactly what's required. When we're providing answers, there'll be times there where you'll need to use some words, so you might need to construct a very quick sentence to explain the solution. And whenever we're providing graphs, it's really crucial that we sketch them over the appropriate domain and that we show all features as exact values. So let's take a look at this first problem. And what I would like you to do right now is pause this video and thoroughly read the question, all of it. So we've got this guy, John North. He's a fisherman, and he takes the height of the tide in the harbour. So that's H. He finds out that it can be modelled by this equation, where T is the number of hours after midnight. So what I'll do straight away with that equation is place it into my CAS calculator. So menu actions define, and notice that I write it as H of X, not H of T. From the question, you'll see that everything relates to the first 24 hours after midnight. So I'll put in a domain restriction that X is between 0 and 24. The other thing that's really important here is that you need to ensure that your CAS is in radians. So you need to just go menu, in fact it's the home screen, sorry. So it's the home screen, settings, document settings, and you can see my angle has been selected to radian. So just getting back. So there's my defined function and I am in radians. That's really important. Unless you are told to put it in degrees, always assume it's radians. All right, A, what is the height of high tide and when does this occur in the first 24 hours? So the high tide will be the median plus the amplitude, because the high tide is the maximum value for this H of X function. So the max equals the median plus the amplitude, so we end up with 7 meters. We're also required to find out when that first occurs. So without knowledge of what the graph looks like, how do we go and work out where that first occurs? We can use our CAS. So I'm now going to go menu, algebra and solve. And I want to find out the value of X so that the height is equal to that maximum height of 7 meters. And you can see I've got 3 solutions here between 0 and 24. The first time it occurs is at 0. So in addition to that answer, I should also have in place there that it is in fact at midnight itself. At the very beginning, we have a maximum high tide. B, what is the difference in height between high and low tides? So we now want to calculate the low tide, so that's the minimum, so it's the median minus the amplitude, and that's 3 meters. The difference between these is 4 meters. C, sketch the function over the first 24 hours. When you're doing this, if you're doing it by hand, it's really important to have an understanding of the period. So remember, the period is how long it takes for the function to complete one full cycle. So how long does it take until the wave starts to repeat itself? Our period is 2 pi on n, where n is the coefficient immediately in front of the variable. So we've got t here, immediately in front of that is pi on 6, so our n value is pi on 6. So our period is 2 pi divided by pi on 6, which with our fractions is 2 pi times 6 on pi, and we end up with a period of 12 hours. So it takes 12 hours for us to complete one full cycle, and that's really crucial. All right, so we set ourselves up as an axis. We've got our t on the bottom. We know that we're after the first 24 hours. So if I go halfway, I've got 12 hours, and I should see a full cycle in that 12 hours. So you can see I just break it up. So halfway between 12 and 24, I've got my 18. And then halfway between 12 and 18, I put a little increment that will represent 15 hours, 21 hours, 3 hours after midnight or 3 a.m, and 9 a.m. here. Now we follow our pattern. We've got ourselves an upright cosine graph. So that was what the pattern should be. So we should start at our max, come down to our median, go to our minimum, go back up to our median, and then up to our max. That's the pattern that we should follow. And we've got some crucial values that we've already calculated in A and B. So we know that the maximum is 7, so that's important for our h-axes. And we know that our minimum is 3. And we also know that the median is 5. So I've got 3, 5, and 7. And now I just follow that pattern with the cosine graph for these critical x values. So we start off with 0, 7, 3, 5 at our median, 6, 3 for our minimum, 9, 5 for our median, 12, 7 for our maximum, 15, 5 for our median, 18, 3 for our minimum, and so on. And that's one full cycle. Okay. D. John North knows that his trawler needs a depth of at least 6 metres to enter the harbour. Between what hours is he able to bring his boat back into the harbour? Okay. So, what I'm going to do is go straight away to my CAS. And I'm interested in solving, so menu, algebra solve, to find the values of x where the height is equal to that 6 metres. Remember that we can only pass through the harbour safely if the height is above 6. So here are my solutions, x equaling 2, 10, 14 and 22. Alright, but between what times is it above 6? What we need to do now is add ourselves a graph and look at what's going on here. So if I go to the home screen and I'm going to generate a graph, I'm going to put in the h of x. Alright, and this is not going to be appropriate domain or anything like that. It's not very helpful. If I go to menu and I go to Windows settings, what my x value is, I might go from -2 just to show what's going on, and I might go to 26. Oops, not that far, but 26. My y values, remember I'm ranging with heights between 3 metres and 7 metres, so I might go from -2 to 10 and look at graphing that. So now here's my function. I've got a clear idea of what's going on, and from here my solutions are 2, 10, 14 and 22. So then it becomes pretty clear by looking at the graph. It's between 0 and 2, and then we won't have a 1 for a while until we have between 10 and 14. So 10 to 14 in time, and then finally 22 to finish it off at 24 there. So they are the times. But let's just verify that. What I'm going to do is define another function. So I'm going to go menu, actions, define. I can call this whatever I like, but I'm just going to call it f of x. And I'm going to make that equal to the 6 metres. Hit enter. So that's defined. And now if I go back to my graph and hit tab, I can put in that defined function, so it's f of x. Hit enter, and there it is shown. And if I can calculate the intersection points, then that will give me all the information I need. So menu, analyze graph, intersection. So I select my first graph. Escape there. Menu, geometry, points and lines, intersection points is what I wanted. I select my first graph, and then my second, and now the intersection points are given to me. So you can see those there. So now it becomes really clear that it's between midnight and 2 a.m. It's between 10 a.m. and 2 p.m. and it's between 10 o'clock at night and midnight again. So when I look at my solutions here, that's what I can easily write down. And the rest of the information is similar to what I've described to you on the CAS. Okay, so here we are with problem 2. What I want you to do right now is hit pause and thoroughly read through the question. Okay, looking at the graph now, you'll be able to see that we've got the distance, and that's in centimetres, and along this axis we've got time going by. What this question is about is a bicycle wheel. Consider a fixed point on that bicycle wheel. As time goes by, the bicycle wheel is rotating. And what we are doing as time goes by is measuring how far the fixed point is above the axle of the wheel. So how far is it above the centre of the wheel? Let's look at this diagram. Here's our wheel. Here's the fixed point. As time goes by, we'll rotate into that position there. You can see that in the middle of the wheel, that will be our axle. So if we have the fixed position of this here, where my cursor is, right in the middle of that yellow dot, then we have a 0 distance that we are above the axle. We'll rotate to this position. Here we are at our minimum value. This is negative 20 centimetres. So that's 20 centimetres below the axle. We rotate again. We return to 0. This is the median of the graph. And in this position here, we have our maximum. Here we are 20 centimetres above the axle. So hopefully that makes sense. Now, if we're looking at that distance, then we're creating this graph here. So our starting point, the fixed position, is level with the axle. So this is it here. We go along, we are now at its maximum. So that means that we are directly above the axle, would be in this position. So perhaps we could be rotating that way. Then we are at our median. So that means that we've gone to our maximum, back to our median. And then rotate through to our minimum. So the fixed point is now down here. And so on. Following that through for a full 3 seconds. Okay, let's start addressing the questions. What is the radius of the wheel? So obviously from there to there, we're talking about being the amplitude of the wave, so from here to here. So the amplitude represents a radius of 20 centimetres. B, how long does it take for the wheel to do one full revolution? So from the graph, you can see that we go through 1 cycle, 2 cycles in 3 seconds. So how long would it take us to do one full revolution? Half of 3 seconds, which is 1.5 seconds. That's explained here. C, what's the minimum distance? Sorry, I should just get to our C. What is the minimum vertical distance reached by the point? Where on the wheel is this? So the minimum distance is minus 20 centimetres. This is when the fixed point is on the ground, i.e. 20 centimetres below the centre of the wheel. So it's when the fixed position is in here, directly below the axle, and that fixed position is on the ground. D, what do the t-intercepts on the graph represent? So what does this position here, what do they represent? So the t-intercepts represent when the fixed point is level with the centre of the wheel. So getting back to our diagram, whenever we're here or here, that's a t-intercept. So it's when the fixed position is level with the axle. Remember, the axle is in the middle of the wheel. That's what that represents. So this is a pretty different kind of a question to think about, getting your head around the fact that we've got a bike wheel and a fixed position on it. As time goes by, the bike wheel is rotating. It's all perhaps a little bit strange, but hopefully you now have a better understanding of it. Here we just got that use of our CAS, and I think I've shown you enough there of how to use our CAS in that previous question. So, just remember that you can plot two different functions on the same graph, look at their intercepts, and that's often a solution. Okay, so problem 3 here. As you can see, it's an application question. So what I'd like you to do right now is to pause this video and thoroughly read the question, get a really firm understanding of what's required in your answers. All right, so you can see that we're looking at the water level inside a lagoon. You'll realise that it changes periodically. So automatically alarm bells should start ringing that this is going to be involving circular functions. Here's the function given to us. So the height of the lagoon in meters is going to equal 0.5 cos of pi on 2 times t, where t is the number of hours after midnight, plus 0.5. And that's given to it here. So the first thing I'm going to do is define that function in my CAS. So here's my CAS, menu actions define, and I can define h of x. Notice that I've got a domain restriction in place here, that x is between 0 and 12 hours. And the reason for that is because in the subparts of B, C and D, we're interested in only being between 0 and 12 hours. So there's my function defined. All right, A, sketch the graph of the function over that interval. Notice that we're including 0 and we're including 12 with those square brackets. When I'm sketching this, I can do it straight away on my CAS, but let's just try and think about the information given to me in the rule. The amplitude here is 0.5, the median is 0.5. We can see that there are no reflections at all, so it's going to be the basic standard cosine graph, but there's a dilation factor vertically, and there's also a dilation factor horizontally, and a translation up of 0.5 of a unit. So they're my considerations. So my amplitude is 0.5, my median is 0.5. So the maximum height I'm going to achieve is the 0.5 plus the amplitude to give me a 1. And that's what I need to be able to show on my h-axis. The lowest value I'm going to have is the median minus the amplitude, so a 0. And again, that's there on the h-axis. I now need to consider the period, how long it takes for one full cycle of the cosine to be produced. So my period is 2 pi on n. N is the value immediately in front of the variable. So here's my function, my variable t. I can think of that as being pi on 2 times t. So the n is pi on 2. So it's 2 pi over pi on 2 to give me 2 pi times 2 on pi, which is 4. So it takes 4 hours to do one complete cycle. And that's clearly shown in the graph here. After that, the wave begins to repeat itself. So halfway, I'm going to have my minimum. And then halfway either side of that, I'm going to have my median. So my pattern for a standard cosine, max, median, min, median, max. That's done in 4 hours. So over an interval of 0 to 12 hours, I'm going to have 3 cycles produced. And you can see that. Notice that the domain is between 0 and 12. So graphically, a better drawing of this would be to have a larger circle here that's been coloured in. Same thing over here to show that I'm going from the position 0, 1 to 12, 1, and I'm including those values, those endpoints. Part B, at what times after midnight is the water level at its maximum? Now for this particular graph, it's very easy for us to read. The question was asking at what times after midnight, so I ignore 0 for time because that is in fact midnight. So it happens 4 hours after midnight, then 8 hours after midnight, and finally 12 hours after midnight. And that's shown here 4, 8 and 12, i.e. these times. Just to show you on the CAS, in case it wasn't so clear, I can go menu, algebra, and solve, and I'm looking for where h of x is equal to the maximum value, which is 1. I'm solving for x. So you can see those values given to us. I ignore that 0 because that is in fact midnight. I'm after for the first times after midnight. Part C, what is the water level at 3:45 a.m.? Give your answer correct to 3 decimal places. So for 3:45, we have to recognise that it's 3 hours and 45 minutes. 45 minutes is 3/4 of an hour. So i.e. the time will be 3.75 hours after midnight. Whenever you're providing this kind of a solution, state the function. So even though I'm dealing with h of x on my CAS, I write it in terms of the variables given in the question. So it's h of t equaling 0.5 cos of pi t on 2 plus the 0.5. So I've stated my function. And now I have the substitution of 3.75 into it. I read it off and it's a fairly exact answer. Correct to 3 decimal places. So 1, 2, 3. I've got this 1. I'm either going to leave it as a 1 or round up to a 2. Look at the next digit, it's a 9, so therefore I round it up to a 2. So it's approximately equal or correctly equal to 3 decimal places, 0.962 meters. Again on my CAS, I simply want to evaluate h at 3.75. Hit enter, and there's my answer. 0.962, correct to 3 decimal places. How long in total is the water level above 0.8 meters in the first 12 hours? So let's just muck around with the CAS a little bit here. If I go to the home screen, and I'm going to plot in that h of x. And you can see it's not very helpful in that format, but what I can do is go to the menu, window and zoom, window settings. I'm going to have x varying between negative 2 hours, and I'll go to 14 hours. I'll completely show everything. My y values, the wave goes from 0 to 1. So I'm going to go negative 0.5. And I'll go to a height of 1.5. So this will show me absolutely everything. All right, so there's my graph. Okay, so that's pretty simple. Now back over here, sorry, there's my graph. You can see it all makes sense. It's in line with what I found here. But what I want to work out for this question is the heights where we had, the times, the values of t, where the height is 0.8. So what I'm going to do now is define another function, and I'm going to call it f of x. So menu, actions define, f of x. I'm going to make that equal to 0.6. So 0.8. Hit enter. Now if I go back to my graph, I'm going to enter that f of x function in. Hit enter. And you can see that these intersection points here are going to give me the values for where we have the height equaling 0.8. So I'm going to go menu, geometry, points and lines, intersection points. Select the first graph, select the second, and there's all my values given to me. So you can see it's fairly congested. It's a 0.59. Whoops. And you can get all of those it's probably a little bit more difficult here on my CAS. But you get the idea is that you can move those and read those off fairly easily. But what I can also do is solve and work out the values. So I can go menu, algebra, solve, and I simply want where h of x is equal to 0.8, and I'm solving for x. And here are the values given. You can read those off there. Now in my solutions, what I've done here is worked out those values, and then I've converted those to actual times. So you can see that 0.59 represents 35 minutes AM, so 0 hours 35 AM, and so on. Now this listing that I've given you is basically the intervals for where the height is greater than 0.8. It's not the total time. So from 0 to 35 minutes past midnight, and then so on to here, and then from here to here, and then from here to here. So it's not too helpful the way I've expressed that. We are after a total time. So let's look at that. Midnight to 35 minutes past midnight is a total of 35 minutes. 3:25 AM to 4:35 AM is a total of 70 minutes. Here we have another total of 70 minutes. And then 11:25 AM to midnight, where we finish this off, is another 35 minutes. So in total, if you add all of those figures up, we're going to have 210 minutes. So the answer that we're looking for here is in fact 210 minutes, or if you like, it's 3.5 hours. And that's the answer that should have been provided. Instead, I've given you the time intervals for where the height is greater than 0.8. It's not the total time that's been given in this written solution. The total time should be 210 minutes.